Hey everyone, thanks for joining. We're in a very COVID-safe room right now. Everybody has their own row, so congrats. It's like being in first class or something like that. Well, I appreciate it. I know we're 3 days in. It's the end of the day, so I appreciate everybody showing up for this. So this is turning SAP data into AI-powered insights with Confluent. My name is Sean Faulkner, and I am head of product in AI strategy at Confluent. This is Rodrigo. He's our head of product in partnerships and ecosystems. And given that we're at the Data and AI Summit, and probably one of the biggest, if not the biggest, AI conference in the world, I don't think that this statement will probably be met with a ton of controversy. But Gen AI and agents are powering new experiences. And I think the interesting thing about this is that if you look back at kind of the history of technology, every decade or so, there are these sort of technology shifts or paradigm shifts that happen from 1970s with mainframes to desktop computing to the internet to mobile to cloud, and then now finally with AI. And with each of those shifts, essentially you have a shift in terms of how consumers interact with that technology and how we actually develop and build technology as well. And I think certainly in my career, I can't remember a moment quite like this in terms of the potential transformative capabilities of a technology when we're talking about AI and agents. And it's really changing, I think, not only the way that we build technology and we interact with technology, but also the way that we think about doing our jobs and the way we think about being an employee or hiring or what it means to have a job, as well as how we consume information. The way that I learn now is changing. Back when I was in graduate school, studying AI and data systems and so forth, when I wanted to learn something new or read a paper, I would read the title and abstract and figure out, is this something I want to spend time on? And then I would read that paper cover to cover and think deeply about it and spend a lot of time thinking about what is novel in this, how does this relate to what I'm doing, how can I use this information? And now I can read the title and abstract and figure out if this is something I want to spend time on, and I can throw that essentially into ChatGPT or Gemini or whatever your favorite LLM interface is, and just start asking questions. And I can create essentially a very personalized journey to how I want to learn and consume information. And I think that's really the next wave of technology that we're talking about, that some of these innovations in AI help us enable, is deep personalization. And this will, I think, create not only my personal education experience, but all consumer experiences will start to become highly personalized, very adaptive. So that's a very, very exciting place to be and a very exciting, I think, future for us. But what does it actually take to build these systems and bring these things to life? The demos all look great, the POCs all look great, devil's in the details. It's actually extremely difficult to bring these things, especially when we're talking about enterprise production systems. And the big challenge predominantly with most companies is really a data problem. Like all AI problems are fundamentally data problems. If you have a messy data estate and you slap a gigantic model on top of it, it doesn't solve the underlying problem. It's, garbage in, garbage out, as they say. And really, real-time data is the fuel of AI. And I think that's more so true today when we're talking about interacting with foundation models and building things like AI agents than probably any other time. Because really, you need a combination of essentially historical, sort of static snapshots of data, as well as essentially real-time signals and knowing what's happening in the moment. And that's because AI agents, which are doing some level of reasoning, sort of similar, maybe mimicking human capabilities, well, humans essentially rely on both forms of information. Like imagine if you were to go and get surgery, and the doctor that was operating on you only had access to the memories and the patterns of essentially performing that operation and didn't have information about your real-time vitals. And they couldn't see you as they were operating because they don't have the signal information into their eyes. How comfortable would you be sitting on that table to get operated on? Probably not very comfortable. So as uncomfortable as that makes us when it comes to essentially a human making those decisions and reasoning, we should also feel uncomfortable if we're building essentially AI agents that also don't have access to fresh information. Otherwise, they're going to essentially be more likely to make mistakes and make decisions that are not going to deliver ROI. However, the big challenge that a lot of companies have, and probably most companies in the world, is that historically, we've really thought about data existing in sort of these two planes of existence within the organization. You have the operational state and you have the analytical state. The operational state's where your apps live, you have your app databases, and these usually are built by one particular team. Platform team owns the deployment and running these things, and then they heave data essentially over a wall into the analytical state where your data team picks it up. And this predominantly moves essentially left to right. And over time, each of these estates essentially grow in complexity, where you end up with a lot of point-to-point connections, a big, essentially dependency graph, and most of this data is essentially moving left to right. And if you need to get data out of this estate, essentially we use a special form of ETL to do that, reverse ETL, to pipe that back out. And perhaps that was okay or reasonable when we're essentially powering dashboards and using that to make decisions. But when we're talking about essentially powering AI systems that all depend on your ability to correctly contextualize the prompt, this system is not going to work. It's going to start to break down. So this essentially just leads to this gigantic mess where most organizations are not in a position to essentially take advantage of these super powerful models. All these things, agent to agent, MCP, the latest, greatest foundation model, these are all amazing technology, but if you're putting that essentially on a garbage heap of data, it's not going to solve the fundamental problem. All right, so with that, I'm going to pass this off to Rodrigo to talk about data streaming and real-time data.
Great. Thank you, Sean, and great to be here. Thank you guys for coming. I know it's very late and the finals are starting, so we'll try to keep you updated on the scores, I guess. Quick show of hands, how many of you are already working with Kafka or familiar with Kafka? I don't want to bore you with things you may already know. Great. So let me just walk you a little bit through the journey that we ourselves have been in, building from Kafka outwards. Starting with Kafka and streaming more generally. It's become a very popular mechanism for joining systems together because what Kafka does is it brings you three distinct advantages. One, it works at really high scale. So you can connect things that are emitting a lot of data and connect it to things that need that data at very high speed and very low latency very, very well. Secondly, it has a lot of resilience. At the same time as we transmit the data, it's actually written to disk. So if you need to recover, you need to rerun the things. It's become very popular because of that. High throughput, low latency, high resiliency. And perhaps more importantly, what this diagram tries to show is that it dramatically reduces the complexity. That's actually the core value prop, which is in the diagrams that Sean was showing before. If you're trying to connect 2 or 3 systems together, or 4 or 5 systems together, suddenly you have an n-squared problem, right? If you have 5 systems and you're trying to create connections between the 5, you have 25 connections. That's a lot. Whereas with Kafka, which implements what's called a pub/sub mechanism, you actually have an n plus n problem. You have 5 systems running into Kafka and 5 systems reading into Kafka, so 10 connections total. That decrease in complexity makes it dramatically powerful, dramatically popular, and that's why we see significant amounts of adoption of Kafka everywhere you go. I'm sure every one of your companies is using Kafka, and so streaming has become the new de facto standard because, as Sean was talking about, data needs to be in real time, but it needs to be in real time at scale. Think Uber scale, think Netflix scale. So you need to be able to service hundreds of millions of endpoints with data that's relevant to them at that moment, specifically to them. And what we also see is the evolution from, instead of just letting the data flow blindly from left to right, and particularly the people in the operational estate that Sean was showing before tend not to know what happens to the data on the analytical side. You need to actually have a mechanism to capture what the metadata is, what the essence of the data is, what the meaning of the data is, and we call that data products. So the idea is that as soon as a new PO gets created in your ERP system, that you create a data product called POs, for example. And so for each one of these different domains, you want to be able to move or shift the responsibility of maintaining the information about the data upstream. And you can do that with Kafka, and you can do it with Confluent, because we give you the mechanisms where you can capture all this knowledge about the data and preserve it in the form of data products. And then on top, you can build derivative data products on top of each one of those. So if you join the orders data product with the customers data products, only you have customers and orders data products. And we see this evolving more and more and becoming more and more adopted, where this old method of developers developing things and then just dumping the data over for the data engineers to try to figure out what the data originally meant, that doesn't scale. You want to be able to preserve the data and transmit the metadata about the data as it flows through. And this is actually, applying a data product thinking to your streams. We see our most advanced customers doing this quite successfully, and that allows them to free up resources to do more with things like Databricks and things like that. So instead of spending a lot of time and a lot of cycles and a lot of money really on, for example, rebuilding the schema of objects that somebody somewhere dumped on the data lake, if you preserved all that metadata through its whole life cycle, you can use those DBUs for something a little bit more value added than just trying to recreate what somebody else already knew. And more importantly, we've gone beyond data streaming, right? We've added more elements to our platform, such as the ability, I said before, of connecting to things that are not streaming native. So sometimes we are in the business of data in motion. We're in the business of moving data, but not every data necessarily lives in a moving object. Sometimes data is in a database, and you want to be able to grab the data from the database. Or not everything knows how to talk about, in Kafka language, so to speak. So we offer you what we call the connect layer, which is the ability to connect to other things that are not necessarily Kafka native. Over 100 or so connectors out of the box. But more importantly, as I mentioned before, governance and preserving of the metadata is actually where it's at. If you want your agents to understand what the data means, you need to offer them metadata. And that all happens in this governance layer. And sometimes you actually need to process the data because different systems throw information in different formats, and you want to unify them into a single format. Or you want to increase the signal to noise in the data by processing it, by aggregating it, by filtering, et cetera. So you want to be able to process the data as it's flowing through, not wait until somebody else picks it up somewhere downstream in the lake. And so the combination of these four items, streaming, connecting, governing, and process, is what allows you to go from a data mess to data products that allow you to ultimately have sort of real-time value everywhere. And now something's, here we go, wrong button. And obviously, the proof is in the pudding. We have a lot of customers very advanced in their journeys in becoming streaming first and using real-time data and data products to power their AI initiatives, as some of them you see here. And more importantly, again, this assumes that you already have some knowledge about Kafka. Kafka was born in the on-premises world, but we as Confluent, which was founded by the creators of Kafka originally, have taken the product, the technology to cloud and made it cloud first. So when you work with Confluent Cloud, you have the separation of compute and storage and networking, which allows them to scale independently. You can scale from 0 to significant amounts without having to do any of the operational work. Very similar to how Databricks and their serverless offering works. That ultimately helps you, again, free up resources from drudgery work of maintaining these massive brokers into using those resources for more value-added services and products. This is my role, we work very closely with Databricks and with SAP. Actually, the demo that we will show today talks a lot about how you can use these products in tandem. So from SAP, you can connect directly using SAP Data Cloud, Business Data Cloud, and to our service, send data replication flows into Confluent, and then move them on either to Databricks or to some other service, to other operational use cases as well. And more importantly, like I said, everything we've talked about has been about streams and data in motion. And very often what we see our customers is taking the data from the operational side and moving to the analytical side. And it's a very drudgery process of dumping the data into CSV files or into Parquet files, and then running a conversion job using Databricks, for example, to convert into Delta, et cetera. Delta and Iceberg have emerged as these standards. They're the equivalent. We think of Iceberg and Delta as the equivalent to Kafka in the analytical world. Everybody wants to have their data in an open format so they can bring the right engine to it. And what we've developed essentially is the ability to insta-magically, and we'll have a demo that we can show, convert the contents of your Kafka topics, of your streaming topics, into Iceberg tables or Delta tables. So instead of having to take all the contents that you have all the data you have in Confluent and dumping it into a logical raw zone in your data lake, I think Databricks likes to talk about bronze, silver, and gold. You can actually, we actually help you just project those contents, the content of those topics, as an Iceberg table, as a Delta table, without you having to do any work at all. And then we register with Unity Catalog, so it just becomes another table available to your users to run queries against. And I think we demo that as well. Anyway, so that's the quick tour of Confluent, where we are, where we came from. I think we all really came to see the demo, which is the next. Actually, no. First, Sean needs to talk a little bit more about data products. Sorry.
So at the beginning, I was talking about these, I guess, like unique sort of data requirements around AI systems today. And I think essentially this is a little bit different than what we've seen in other eras or waves of AI. So we've kind of gone through 3 waves, starting with predictive AI. This is really our purpose-built models. This is really the AI that I learned in school. I spent time as a researcher. We've been using these successfully in software for decades now, and they'll continue to be used as well. It's not like these are replacements for them. They're all complementary. But with predictive AI, essentially what you were doing is you're taking very application domain-specific data, and you were training a very application domain-specific model. And these are great, but they are sort of built for a specific purpose. It's hard to pick up your fraud detection model and start doing image classification with it, essentially. So in a lot of ways, it's like a reflex. It's learned once, it's hardwired, super useful, just like when I touch a hot stove, my hand reflexively comes off of it. That's useful for my own protection, but not very flexible in terms of learning new behaviors. And then along came generative AI and foundation models, these massive models that are trained on essentially everything that's available publicly. And essentially this is bringing in the brain to this equation, where they're able to reason and respond to conversational requests in real time, and essentially mimic conversations as if the response is human generated. And here we can go beyond this kind of reflexive action of just predicting something like customer churn to actually being able to converse automatically with someone in a customer service scenario, for example, so that we can answer questions and we can ground the knowledge, the context, using techniques like retrieval augmented generation and other ways of essentially correctly contextualizing the prompt. And then with agentic AI, what we're doing is really going to a full software system where we have a full body essentially now. So the model is acting like the brain to be able to do reasoning and make other types of decisions, but through essentially tool use and resources and other factors, you can essentially reason, coordinate, and act based on the environment. And if you're bringing in real-time signal information as well, you have that combination of real-time as well as historical data when you tap into things like Databricks or other data sources. So now we can go from just, hey, I'm a customer service bot that kind of knows how to respond, to actually being able to make decisions. So I can decide or automatically decide that I should give a refund in this scenario, or I should actually then go and execute that refund through some sort of tool action. So we're going into something that's a lot more sort of proactive and be able to make decisions on its own. However, actually building and scaling things like agents is really complicated. There's a lot of, for a singular agent, a lot of dependencies. You have various data systems that you're hooking into, both externally, internally into the company, depending on what you're trying to solve. You have potentially feedback loops through users or other ways of doing automatic feedback that you need to take into account. You're using a model that's stochastic in nature to make certain decisions. So you're dealing with a certain amount of non-determinism. And presumably, this is all going to end up being a distributed system problem as well when you're running this essentially in production. And realistically, no one's running and deploying essentially one singular monolithic agent. You're really decomposing the problems into a smaller set of sub-problems where you have purpose-built agents that all kind of work together to solve complex problems. So you end up with a multi-agent system. And the multi-agent system, essentially, as these things scale, you get more and more of these interdependencies between the agents that are communicating with each other, the tools they're interacting with, the data sources they need to talk to. And this becomes essentially the same quadratic explosion that Rodrigo was talking about earlier. And these become really, really brittle over time. So luckily, we have seen, as we've talked about, this problem in the past. So like 15 years ago, when we started to break up monolithic systems because of scale issues, we broke them up into essentially microservices. So now I can have, my microservices resourced differently. I can have different teams working on them. The code base can be split up. I can deploy those in different ways. But if I'm building and scaling those with essentially point-to-point sort of request response dependencies, then this becomes very challenging and brittle over time. And microservice A needs to know a lot about microservice D, where it's sending information to, because if it doesn't, then it could potentially overrun it with too much data, take it down, and then the whole graph structure is impacted by that. So the way that people solved that was essentially through event-driven architecture, going from this quadratic explosion to a linear number of dependencies, And this is how some of the largest systems in the world, like Netflix and Uber and so forth, run thousands and thousands of these things. And I think really the great gift to the world that Apache Kafka gave us was this decoupling in the services, decoupling in the teams, because now microservice A is just producing events. And other microservices are consuming those events, but they don't need to know explicitly about each other. And essentially this same architectural pattern of event-driven architecture is the same way that we need to be thinking about building and scaling multi-agent systems. Because from a deployment standpoint, like what is an agent? An agent really is just a microservice with a brain. It's a microservice that has access to a model and some contextual information. But you're going to end up deploying and running essentially a bunch of microservices that all need to talk. And that brings us back to essentially data streaming, where events essentially can become the shared language of multi-agent systems, where the agents don't have to have explicit dependencies. They're just producing and consuming events. And we can use the durability, the exactly once message delivery that's all inherently built into things like Kafka. We can use Flink for processing those things, doing certain orchestration tasks. And we can also replay these events against essentially production live data as we need to evolve these agents or iterate on them. So that takes us to the part that lots of people want to see is the actual demo. So I'll hand it back to Rodrigo to handle.
Thanks, Sean. So I'm going to walk you through a demo that it simulates a very real-world use case, which is analyzing returns. So in this case, we've developed a use case where the actual returns are tracked in SAP, which is very common, right? SAP is used very widely as a mechanism for tracking assets and manufacturing and inventory, et cetera. And then we're also adding some things like the actual reasons why customers are returning it, which are captured somewhere else on a website, and then understanding how to use that data for both analytics as well as machine learning and connecting it to Databricks and MongoDB and a couple of other things. And so the demo actually starts in SAP. This is what's called the Business Data Cloud. Don't worry, you don't have to understand it. It's just this is a place where you can connect to different services within SAP and create what are called replication flows, which essentially allows you to connect to objects inside SAP without having to necessarily understand the technical structure of the objects. They have what they call a semantic layer that allows you to connect to these objects by name. And then you can also connect them to, as you saw there, to Confluent specifically. You can configure the connection to Confluent as you see here, give it a name, specify your authentication. Sometimes you really always want to connect to the schema registry, so you capture, as I said before, the schema and the metadata about those objects. And more importantly, this connector is bidirectional. So you can use it to both extract data from SAP as well as bring back data flows into SAP, which is actually what we'll demonstrate today. So after you've configured this connector, which we're not going to do in this particular, it's pre-configured already for the demo, it's going to jump over to the Confluent UI any minute now. Here we go. A couple more seconds before it jumps over to the other. Make sure it's not locked. Here we go. Okay, so now we go over to the Confluent Cloud UI, where this is your home page, and we're going to show you how to navigate a little bit of it. Specifically, we're going to go through the lineage page. And so here you can see all the different data flows as they go through our platform. Green are connectors or sources of data. Blue are topics, which is how you store the data. And then purple are the operations that you perform on the data as you go through. So the upper line, the line at the very top, is the line that has the data flows from from SAP, sorry. You can see right there, we're capturing all the returns, the return feed from the ERP system. But as you can see here, when you try to preview some of the data that's in that topic, it's very sparse. It only has the facts of the data, the identifiers for the data. It doesn't really tell you the reasons why things are being returned. It just tells you that something has been returned. We need to join this data with the database or the data stream that tells you the reasons for the returns. And that actually happens if you go back to this operation here, essentially using a SQL statement that runs on top of Apache Flink, or our implementation of Apache Flink. You can essentially join these two streams, and out of that you get this enriched returns feed that tells you not just that something was returned, but why it was returned. So it goes down and tells you, oh, this one didn't fit properly, for example, in this particular use case. So now that we have this enriched data feed, we can do a number of things. And again, we have this single topic that has this enriched returns feed, and we can send some of this data, for example, to MongoDB, in this case, where we're simulating that it's that the in-store application is running on top of MongoDB. So now the associates at the store can look at the history of somebody or why they've returned different items. We have this sort of connector to MongoDB. The data just goes to, I'm not going to go into MongoDB here, but then we can also send the data back to SAP. Maybe the inventory manager wants to understand a little bit better what's going on, so he wants to feed that data back into SAP for analytics. So we come back to SAP. You can see that's the topic, the source topic that it's connecting to. And then on the right, you have the table inside SAP DataSphere, which is the analytics product that they're using. You can actually see, and actually we'll go into the table itself just to show that you're not just getting, you're now getting this enriched data feed back into DataSphere in real time and continuously updating. So going down to the SAP table, it's going to ask for the preview, and you will see essentially that we have the enriched data set. So that's great. Now you can run maybe some visualizations or something on top of this data inside SAP, but we're in the Databricks show, so we want to show how you can actually make this data available to Databricks for perhaps more advanced things like machine learning or running some data science use cases on top of it. Now, as I said before, usually you would dump this data and have to convert it into Delta. With Tableflow, which is a feature that we recently GA'd, all you have to do is essentially point us to the location where you want this data to show up, point us to the Unity catalog that you want this data to be visible to. And in this case, for example, we're saying, hey, this particular topic should be visible to Unity. And going over to Databricks now, again, you can now see this table, this topic as a table inside the Databricks UI, where you can very quickly, again, we're going to show that all the elements that I showed before are there. And now if you go to actually select the data or sample the data, you will see that now you have the enriched returns flow in Databricks in Delta format. So now you can actually start running some interesting machine learning or some advanced use cases on top of it. And when it's ready, return it back to SAP. Now, I'm going to go a little bit off script here. This is also going to be available for SAP Databricks if you guys are interested in the implementation of SAP within Databricks. So this is also going to work very well with SAP Databricks or standalone Databricks if you already have that. So that was the demo. And so just to summarize, right, we're all about, deploy your AI strategy by what we call comprehensive data products. So there's going to be a lot of things emitting data products on the operational side. You want to make those data products ready for AI, so that when you build your models, when you release your agents on them on Databricks, you don't get garbage in, garbage out, but you actually get to success quicker. You have the reassurance that you're using the right data for the right use case. And more importantly, the data wants to flow the other way, as Sean was saying. So you want to have these AI-fueled real-time apps and real-time data products flowing back into the operational world. We are the connective tissue that's going to enable you to do that and connect both sort of the analytical world and the operational world. We're very proud of the partnership that we've also developed with Databricks. You can get started right away. We have this 30-day free trial. If you want to scan the QR code or just go to confluent.io or cloud.confluent.io, and you can sign up for a 30-day trial, $400 in free credits, and just get going.